So my name is Ryan Davis. I work at Utah State University. My official title is Arthropod Diagnostician. I'll tell you more about that in a second. My general topic today is just pest management basics. In particular, how to select insecticides or pesticides and recommend different pesticides to people. It's important to understand some general background on pesticides to make the best recommendation, I think. But just a little bit about our lab first. So like I said, we're up in Logan in Utah State University, and Brittany mentioned, if they can't figure out what something is at the county offices, they send it to the lab. Well, it might be scary, but that's me. And I have a bunch of information up there, a bunch of insect identification keys, and I can identify, a lot of different things. And then once I get the identification down, we can help write an integrated pest management plan for you. And it doesn't matter if it's urban pests, indoor pests, outdoor pests. We can do that. And so on the arthropod side, so the insects, the spiders, ticks, mites, all of that sort of stuff, we do have a plant pathologist. And so if you ever have a turf sample that you want to send up, plant disease sample, Claudia is the one who usually handles that. And then we have other people up here doing great things, but for time's sake, I'll skip them. But anyway, if you get one thing from our website or from this talk today, it's our website right here. That's utahpests.usu.edu. And when you go there, this is the page that comes up, and you have 4 different things to choose from. Probably the 2 that you use most is this integrated pest management, and then also the Utah Plant Pest Diagnostic Lab. So this is where you can find instructions on how to submit a sample. It's $7 to have a sample identified and a plan written up, which compared to Oregon State University at $90 a sample, we're a steal. I don't know why we charge it at that price. But anyway, so you can find directions on how to submit things at that website. And another thing that we started doing on this website recently was all the samples that come in and I identify and Claudia identify, we put them all on our website. And we try to keep up with it during the summer, so there'll probably be a week or 2-week lag time. But we take pictures of everything, we put up what it was, and then we put links to fact sheets in there. So it's just handy because you can go on there and see what's being submitted to me, and that might be something you're seeing on the landscape at that time too. So go and check that out. The other really great resource is this integrated pest management part of the website. Marion Murray runs that. She runs the IPM program in the state, mostly with the fruit growers, especially down in this region. But she has these things called IPM advisories. And what she does is she goes out and scouts in different settings. She does small fruits. She does, tree fruits, landscape pests, and then there's also a turf advisory as well. And you just go on this website and you sign up for those for free, and they just come in your email however often they're published. And the great thing about this is she tells you what's on the landscape right now in these different settings and what you can expect to see in the future, because we can predict for most pests, based on the accumulated temperatures, what's going to come out next. So that allows us to time our insecticide sprays to be right at the proper time instead of just putting stuff out there and hoping that the pest will show up. We can actually time it using models and weather data. There are weather stations all around the state. So that's that. So check those out. Oh, and also fact sheets from this website. You can click on fact sheets, and they're broken up into categories. You can't see this, but tree food, small fruit, landscape ornamentals, forage field, etc. We have over 200 fact sheets on that website. All the common pests and diseases, and maybe weeds are on there too, that you might find in Utah. And these are great because they give pictures. Extension has required that we started updating all these fact sheets. So a lot of the fact sheets now have really nice pictures of the pests. They have biology of the pests, and then we give control recommendations, not only the chemical side but also the non-chemical, which is what I'd say in my job. I rarely recommend pesticides. I try to talk people out of that if I can. Some people just want to know what to spray, so I tell them organophosphates work great. Anyway, so the general outline, we'll cover integrated pest management first. Insecticide resistance management. Maybe you've heard of this IRM concept. Maybe you haven't, but we'll cover it today. And then lastly, making pesticide recommendations. And the couple of things I have up here right now, I don't know if you can see this, but this is a pie chart, and it's basically the pesticide use by industry. And so this big green part, that's agriculture. Okay, so they're using 77% of the pesticides that we apply. And then the next biggest one is industrial, government, and commercial. And then finally here we have the one that we're concerned with, home and garden, coming in at like 6% of pesticide use. So we are a small niche in the market, but important nonetheless. So, and then I found this graph too. This is from 2001 through 2007. The top 10 pesticides, and so pesticides we include rodenticides, insecticides, herbicides, fungicides. Those are all types of pesticides, right? Top 10 pesticides for homeowner market, 7 of them are herbicides. So that's what most people are using pesticides for, is to control weeds. And we see that same thing in schools. I work with schools to try to get IPM implemented. And a bulk of their chemical use is out on athletic fields and playing, playgrounds and things like that. But as far as insecticides go, which is what I deal with, carbaryl, is, I guess, number 3, pyrethroids, and then malathion, which is a organophosphate. So carbamates, pyrethroids, and organophosphates are the top categories. And I don't know why, but the neonicotinoids, these systemic insecticides like Merit that you've probably heard of, or Bayer Advanced 12-month tree and shrub, those have an active ingredient that is, I think, one of the most commonly used around the world in agriculture. Maybe not so much in homeowner situations. Okay, so integrated pest management. Who's heard of this term? Okay, like half. That's good. The overall premise is to promote plant and ecosystem health by limiting pesticide use. And so how do we limit pesticide use? We try to take a preventative approach. Right? A lot of people, maybe even including myself on occasion if you get lazy, you pretty much plant the garden, plant the trees, whatever, and you don't think about anything. You don't plan in advance. And then all of a sudden, pests show up, and you take them to the store, and you say, what is this? What can I spray, right? And that's a total reactive approach, and that's against what IPM is all about. So IPM, we want to prevent pest problems from happening to begin with, and then we don't need to use pesticides. So that's what we try to promote. As part of IPM, monitoring and scouting are something we do on a regular basis. And those are pretty obvious terms, I think. Just if you're out in the garden working, out in the landscape, don't just be pruning and not looking at everything else. Look closely at the plants, look closely at the trees, and see if there are pests on there, or if there are any signs or symptoms of problems. And try to catch things before they explode into major problems. Because things are a lot easier to control before they get out of control, right? And I talk a lot about bed bugs, and that's very true of bed bugs. If you can catch them within a month and a half, pretty good success rate. If you wait longer than that, good luck. Anyway, another thing is this concept of thresholds. A lot of people have zero tolerance for pests. I used to be that way before I got this job, but now I plant a garden just to see what kind of pests I can get. That's the fun part for me, and I get some food out of it too, really. But anyway, so there's thresholds, and we have economic thresholds and aesthetic thresholds are the two major ones. Economic maybe doesn't apply to home gardens so much, but if you are going to lose a tree to a pest, then that would be an economic loss, right? You have to cut the tree down, that could cost a lot of money, then you have to replace the tree. So a little bit, maybe aphids on a tree, not a big deal, right? They don't necessarily cause a lot of harm to a tree. But if you had bark beetles in one tree next to another tree of the same species, then that's a tree that you would want to protect because there's a good chance that one's going to get taken out. So anyway, we have to set these threshold levels, and you should have some tolerance for a certain level of pests, and that's determined by you or by plant damage. Does that make sense? Going to use multiple tactics based on pest biology. This is our IPM pyramid. And so first we have prevention, right? We already talked about that. But then we have cultural and sanitation. I'm going to talk about these things more in the next couple of slides, so I'll just list them. Physical, mechanical, biological controls, and then we still have pesticides up here. We're not saying we're never going to use pesticides. I mean, they're still a great tool to have in the case that you need them, but they make up the smallest portion of this IPM pyramid. And again, we want to limit chemical applications, follow label rates. We can limit chemical applications by timing them to insect life cycles. So go online and get those IPM advisories, and she'll tell you what to expect on the landscape. And so instead of spraying on a calendar-based schedule, you can start timing your sprays for specific pests at specific times. And then we'll talk about insecticide resistance management soon. So what does IPM begin with? I mean, really it begins with thinking ahead and planning out the landscape properly to minimize pest problems. But since most people don't do that, where I see people is whenever they have a problem. And so they usually show up with a plant or an insect, and they want to have it identified. And that's the first part of IPM, is to have a proper identification done. Because that can tell you everything about the pest. Its biology, when you expect to see it out, how many times a summer is it going to go through a generation. And you're like, wood borers might go through one generation every 2 years, versus spider mites, which can reproduce, go through 13 generations a summer. So things like that, it's important to know, the biology. And that helps us come up with control strategies. And what we find at our lab is probably 50% of the stuff that comes in isn't caused by a living thing. It's not an insect, and it's not a plant disease. It's just abiotic. And the most common ones we see are environmental things like, she mentioned before, the winter damage, sun scald, definitely improper watering, improper fertilizing, misuse of herbicides is a big one we see. Improper planting is huge. I mean, it takes so long for improper planting to manifest in a tree that people wonder what's happening to the tree 7 years later. And I tell them to dig down into the ground around the tree and see what's going on. And a lot of times it's the case where they planted too deeply or didn't cut the cage or whatever. And then also, as Brittany mentioned, identify the plant host and know what it looks like. So, some plants look kind of funky to begin with, and they might not have a pest problem. Especially like variegated plants. If you don't know what variegation is, I guess everybody in here does, but some people don't. And then they think the plant has like a bacteria or a virus or a fungus or something like that. And instead of seeking advice to begin with, they just go out and purchase a bunch of fungicide and lay it on thick, right? More the better. So anyway, know what plant you're dealing with and know what it's susceptible to, what it should look like, etc. So here are basic things we're going to cover: the cultural tactics, mechanical, physical. And I don't know if there's pressure in your industry to push chemicals because the profit margin is good. But by recommending these other kind of techniques, I mean, you can still push different products. Maybe you're pushing monitoring traps or row covers, something like that, rather than pushing 7. So this is all good stuff. So prevention and planning ahead, that's sort of the cornerstone here. Select the proper plants. My favorite example of this, of course, is quaking aspen. People love to plant that in the valley, but I mean, these trees are marked for death when you put them in the ground, right? Whenever they get about 8 inches in diameter, man, they always get poplar borer, and they always get some weird disease where the branches start dying back and the leaves have spots. Cytospora? I don't know. Anyway, so yeah, when I moved into my house, the first order of business was to make 5 pruning cuts on 5 trees in the front yard, and I got rid of those pretty quick. Because they all look like this. They look like crap, I thought. So I took them out and put in some drought-tolerant plants. If you think about where this tree grows normally, it's like over 6,500 feet, 7,000 feet in the mountains on north-facing slopes usually. So they like cooler, moister habitats, not living in the valley. So you're pretty much asking for problems there. And there are all sorts of examples like that, of course. So selecting the proper plant. What about resistance? Some plants are more resistant to pests and diseases than other plants. Think about turf for a second. One of the primary turf pests we get in our lab is necrotic ring spot, and this year was particularly bad. Like A lot of necrotic ring spot. And it's because people like to plant Kentucky bluegrass. Well, there are other options for turf, right? We could recommend perennial ryegrass, and that is, not susceptible to those diseases. So instead of going out and spraying fungicides, which is what people always want to do, and they're largely ineffective against necrotic ring spot, we could aerate the lawn and then overseed with perennial ryegrass, and over time sort of convert the lawn over. And for the most part, it's pretty similar to bluegrass. The guy who runs the turf program at Salt Lake City School District told me that it's, a little bit more drought tolerant, a little more insect resistant, definitely more disease resistant. The color's very similar. The biggest thing they noticed was that on playing fields it was slick. It was more slick than Kentucky bluegrass. So now they use a mixture of Kentucky bluegrass and perennial ryegrass to get the traction but the benefits of the other grass. So pretty interesting. So look for resistant things. Just in general, plants that grow really fast usually have more pest problems because they're devoting resources to growing instead of protecting themselves. So poplars, I just planted 8 poplars along my house, but it's just because I'm sick of looking at my neighbors. I plan on putting something else there in front of those trees, and I'm going to cut those down in like 10 years when they're 80 feet tall. Anyway, so avoid susceptible plants. What I mean by that, don't recommend plants that are outside of our hardiness zone, for instance. What do we know about soils in Utah? Dirt? Yeah, they're pretty dirty. What about their pH? Right, super alkaline, right? And that has a tendency to tie up iron in the soil, right? So don't put in plants that are susceptible to iron chlorosis. I mean, I had a girl bring in a sample of blueberries to the lab. I was like, who is growing blueberries in Utah? My dad is. Sorry. Anyway, and then she informed me that he's doing quite well growing blueberries in Utah. So just, pick things that do well in our soil here, and that'll prevent problems in the future, because chronic chlorosis over time will weaken the tree, and then pests move in, and you have to start spraying stuff to combat that. And anyway, that's what you want to start out with. Start out with pest-free plants. Don't go to the nursery and buy something that's covered in scale and bring it home, because automatically you have a problem right up front, and then it can spread to other plants. So make sure you do an inspection of the things you're buying before you bring them home, because a lot of times they have mites and thrips. Things from greenhouses can have those. Scale's a common one because it blends in so well with the plant and the branches. So look really hard for hard scales and soft scales, aphids, spider mites, thrips. Try not to bring them home with you. They'll eventually find you anyway, but it's good to start out without them. Diversify plant selection. This is pretty key. People seem to love to go to the store and buy 10 blue spruce and then plant them all in the front yard, right? And then when a disease comes through or bark beetles come through, they all get wiped out at once. Or a couple of them get wiped out, and then they have to spray all the other trees with carbaryl, once or twice a year, which is a unnecessary use. If they had just planted a blue spruce, a fir, a pine, and mixed it up like that, then the beetles that attack the spruce, they're not going to attack the fir. They're not going to attack the pine because they're species, host specific. So diversification is pretty key. Insects love monocultures of things. So as much as you can diversify, the better. Plant properly, that's a no-brainer, right? Like if you're going to recommend plants for people to put in the ground, maybe you should also give them a brochure on how to plant that tree or plant, because that's going to save problems in the future for sure. Keep plants healthy, properly water, properly fertilize. Is there such a thing as over-fertilizing? Yeah, there is for sure, right? People see that their tree's starting to decline and they blast it with fertilizer. But actually too much fertilizer makes a plant more enticing to pests than not, because it kind of improves the nutrition of the plant, and those leaves become a better source of nutrition for the insects too. And in reality, a little bit of stress on a plant is actually better than no stress. Because I don't know if I want to get into that. Let's just say usually a little bit of stress is better than none. Because it forces trees to stop, or plants to sort of not grow as much and put more energy into defense rather than growth. And so that's okay. Mechanical physical controls. Barriers and screens are one of my favorites. So these are some products that you could push instead of pesticides. Like floating row covers, for instance. Screens and barriers. I mean, what a great way to keep, like cabbage moth off your vegetables, right? It's just a physical barrier between your plants and the pest. Where these don't work necessarily is where plants need to be pollinated via bees or something like that. Then you actually have to lift those cages up once in a while and let the bees in, which also can let pests in. But just in general, I like to use these barriers and screens. Traps and bands. Can you think of some pests where putting a sticky band around a tree might be useful? Yeah? Okay. Well, I have a couple examples, believe it or not. A couple interesting ones, and this has to go with insect biology. Cankerworms, for instance. The female moths don't have wings. And so the larvae are on the tree munching on the leaves, and they drop off to the soil to pupate and turn into that adult moth. So the females, they don't have wings. So when they come out of the soil, they got to climb back up the tree. So if you had it wrapped with something sticky, it would intercept them before they got back up there. So they wouldn't mate, and they wouldn't be laying eggs up in the tree canopy. So that's one easy way that you could potentially reduce something like cankerworms. Another thing you don't think of, I heard of a really neat study at a conference I was at, and they were studying aphid communities in trees. And just a bunch of maple trees along a road. And you may or may not know, but a lot of aphids are in association with ants. So the ants are providing the aphids with protection, and in return the ants are getting the honeydew that they excrete. And so what they did was just put bands around half the trees and then left the other trees open. And what they found was just by excluding the ants, the aphid populations crashed. And they weren't an issue anymore because they weren't there to protect the aphids. And on the trees that they left where they let the ants go up, those aphid populations stayed abundant. So cool stuff like that. And the same goes with managing ants. If you have ants, a lot of ants like to tend aphids for honeydew. If you can control the aphids, it takes a food source away from the ants, which then if you're using a baiting program, they're more inclined to go toward your baits because they don't have this alternate food source. So all kind of different cool things. Tillage, I don't know how important that is. The idea there is that some pests overwinter in the soil, and so if you turn the soil up, they'll be exposed to cold temperatures and die. Sanitation, favorite example again is, I'm a bark beetle guy, that's what I studied a while back, but my favorite sanitation example is the spruce dies in the front yard. The owner cuts it down, cuts it into nice 16-inch logs, and then throws it underneath the other living blue spruce, right? And then next spring, the beetles that are still under the bark of those logs, they emerge and then kill that tree. So Whitney Cranshaw calls that the butthead theory. But anyway, so yeah, sanitation. If you have something that's covered in pests and you prune it out or you cut it down, get rid of it. Don't leave it on the property, yeah. I've heard people ask me like, oh, well, what about no-till and the effect it has on the soil structure and all of that? That's all valid stuff, which is why I kind of was going to skip over that. But yeah, like things like, think about tomato hornworm. I mean, they're overwintering in the soil under there, and if you turned it over, I don't know if I'd do that or recommend that. I mean, it's just something I read and thought was interesting. So yeah, maybe not use tillage so much, but I don't know how effective that's going to be. I mean, the cocoons would have to be completely exposed. Oh, the last mechanical one is the water spray. I mean, things like aphids and mites, once they get knocked off the plant, they have a tough time getting back up there before they die. So, yes, in some cases, just spraying things with a strong stream of water can be an effective control. Okay, so the different chemical, when I think of chemicals, I broadly in my mind break them into two different categories. That being, we call traditional pesticides, what we call broad spectrum pesticides. And maybe you've heard of this term, maybe not. I'll cover it on the next slide. So there's the broad spectrum or traditional, and then there's the selective pesticides or the reduced risk or softer pesticides. Things like microbials, soaps, oils, dusts, botanicals, for instance. So the traditional pesticides, they're what we call broad spectrum, right? And here's a perfect example of that. This is one of the most common things that people use around the house. And right here, it says on the label, kills over 100 listed insects. And not only is it killing insects, but there's a tick on there. So it can kill things from different classes of organisms. So people can use this for spiders, insects, whatever. And the take-home point here is that if it can kill over 100 pests, then it can kill even more beneficials, right? I mean, because it's not selecting for a pest. If you put a broad spectrum chemical down, not only does it get your pest, but it gets everything else too. And in a lot of cases, it's the pests that have the faster reproductive cycles. And so when you kill off your beneficials, the pests sometimes have faster life cycles, and so their population just booms because the beneficials aren't there to keep it under control. So in some cases, by using broad spectrum insecticides, you solve your problem in the short term, but make it a lot worse in the long term. And the common groups here are the carbamates, organophosphates, pyrethroids, neonicotinoids. And if these words seem really alien to you, you should make them not alien to you. You should read about them a little bit. And I have a handout here. I only have 37 of them. But anyway, you can grab one of these. I'll talk more about it in a second. But it sort of outlines all these different insecticide groups for you into neat little categories. Talk more about it in a second. Okay, so the soft pesticides, generally when I talk about these, I mean desiccants, so those things that dry insects out, suffocants, they're suffocating things, membrane disruptors, microbials, and botanicals. And you guys know what diatomaceous earth is? Maybe you've seen this before, but they're like marine algae, and now have been fossilized in the ground, and so they go in and dig those things up. And the shell around here is actually silica. It's glass, right? So they pound that up into a powder, and when you apply it to an insect, especially soft-bodied insects, the insect has that hard outer shell, right? But one thing you don't really perceive with the eye is that the insect's also covered in wax. And this stuff, kind of cuts the wax and it absorbs the wax. Then the insects just dry out slowly because it's that wax cuticle layer that's actually keeping moisture in the insect. So if you use something like this, it works well. It doesn't work fast. It takes a week or two to work. But for some pests, it's pretty good. In a garden situation, if this stuff gets wet, it's ineffective. So you'd have to apply it very frequently. Anyway, but I usually recommend this stuff for indoor pests. Like people often have bed bugs and can't afford real insecticide professionals or pesticide applicators to come out and control things. Diatomaceous earth is one thing we recommend to sort of keep things from exploding. It's good for roaches. And so a common one is this Mother Earth D. There's Dryicide, Safer brand. Mother Earth D, I do a lot with bed bugs. So this right now is the most effective desiccant against bed bugs. I don't know if you care or not, but it is. The interesting thing about applying dusts, do you think you just grab a spoon and start flinging dust? So if the layer of dust is too thick, things just avoid it and go around it. So what you want to do is like this, for instance. This bottle is designed to be a puffer, and so you just want to puff so it kind of goes into the air and then settles. So think of like looking at a coffee table with the sunlight coming through the window and you see that fine layer of dust, at least in my house. That's what you're going for, is a very fine layer of dust. So insects don't realize it's there and they crawl over it. If it's a pile, they avoid it. So they come in puffer bottles, but they also sell like little handheld puffers, and if you're a professional, they sell like battery powered or electrical ones that puff out. You could do the whole perimeter of this thing in 5 minutes. So. And dusts work best on soft-bodied insects and some indoor pests. So usually like aphids and mealybugs. And again, they lose their effectiveness when they're wet. Another desiccant is boric acid. And not only is it a desiccant, but it's also a stomach poison, which is why it works well for roaches. Because roaches, you put some of this out and they crawl on top of that, and they love to clean their legs and stuff when they get back to their hiding spots. And they ingest this boric acid, and that's a stomach poison, so it kills them. It also has some desiccating properties, though. So that's and this, unlike diatomaceous earth, is effective, after it gets wet. So it can still be active after it's been wet. Membrane disruptors. insecticidal soaps. These are great. I always mix up, I get a little dish solution at home and I mix up my own soaps at the house, and I have a little spray bottle, and when I'm weeding the garden or doing whatever in the garden, I hit aphids and soft-bodied things with the soap. I attempted to eradicate squash bugs last year from my house with this. It didn't work. They pretty much leveled half of my squash plants. But anyway, the important thing to remember here is watch out for phytotoxicity. So if you make a homemade solution especially, those soaps aren't really designed to be put on plants like these ones are. And so if you go and you spray all of your plants with an insecticidal soap before you've tested it on a couple of leaves for a few days, it could kill everything. So phytotoxicity is, the leaves dying, the plants dying. They suggest like the liquid soaps versus detergents, so soaps versus detergents. When I've done it in the past, and I don't know if I had no reasoning behind this, I've always used the organic, that 7th generation stuff. But I've also used just liquid Dawn. If you want to learn more about that, there's a great fact sheet from Colorado State University. Just go on Google and search insecticidal soaps and CSU for Colorado State University, and that pops up. And he actually gives dilutions, so many tablespoons per liter or gallon or whatever of soap. So yeah, check it out, and then it has more information on the types of soaps you might want to use. But definitely always recommend that people try, don't just spray everything at once. Like try a couple of the leaves of all the different plants you want to treat, and then wait a week and see, is it going to be okay or not. And then also, you don't want to spray this stuff during the heat of the day, like oils. You want to spray it in the morning when it's cool or in the evening. And as soon as the soaps are, dry, they're ineffective, right? So you have to come in contact with the pest you're trying to kill. And then as soon as the soap's dry, that's it for them. So it's a one-shot thing. Right, so that right there only works when wet. Horticultural oils, these are called different things. It used to be, that oils were different viscosities, different thicknesses. And so you would use the thicker stuff before the leaves came out and the thinner stuff in the summer. I think for the most part now, most of the oils can be used any time of the year, but we still use these terms like dormant in summer. And now that refers to a time of year. So a dormant oil would be applied, mostly to get things like aphid eggs that are overwintering on a tree. We would apply those in the dormant period, so before the buds break open. And then we have summer oils, things like that. So these work great, again, for soft-bodied things, scales. Oftentimes people mix oils with other pesticides to, give them a fast knockdown, and then also the effectiveness of suffocating things. These are only effective when wet. As soon as they dry, their residual is gone. Residual meaning the amount of time they will continue to kill things. And then again, watch temperatures on these. Don't apply midday in the summer, for instance. So I think 80 is sort of like the cutoff. So make sure it's below 80 degrees when you do this stuff. Microbials, these are great. The big problem, so they're very targeted usually. Like when you use BT, for instance, to kill caterpillars on vegetables or something, they're usually very specific to a particular pest, which is great. The downside is we live in Utah and it's very dry and very hot, very sunny. And those things tend to work against microbials. Like fungus, for instance, this Beauveria bassiana, or I'm not quite sure how you say it, but it's a fungus that people use sometimes. Maybe it'll work in the spring here, or if you watered very frequently, but usually it's so dry here, these fungi are hard to get working properly. Nematodes, these also need a lot of water, so if you're going to apply them for soil pests or turf pests, you need a lot of water, right? And they are developing strains that are more drought tolerant. So look for that in the future. And then there are other microbials. BT was one. There are viruses you can use. The environment, the heat, the sun, it tends to break those things down and makes them lose their effectiveness. And the other thing is that a lot of times those products are slow acting. So don't expect to go out there and apply a microbial and see things falling on the ground, right? It takes a couple days or a week or so to actually work. Botanicals, I guess what I want to point out about botanicals here is that just because they are derived from plants doesn't necessarily mean they're any less toxic than the synthetically produced things. One that people like to use a lot is this azadirachtin neem. It comes from neem trees, and it comes in an oil form, right? And here's one called Trilogy, and just by the name you can tell that it's good against 3 different categories of pests. So this Trilogy supposedly can act as a fungicide, an insecticide, and a miticide. And for a homeowner on a small scale, that might work well. I wouldn't recommend it on a large scale. Pyrethrum, so you've heard the pyrethroid insecticides. Well, where did that chemical originate? In the pyrethrum daisies. So they isolated that chemical, and they have organic versions of this pyrethrum out there, pyganic. And so that's one thing. But the chemical companies took that and then synthesized it into synthetic insecticides. So really, the pyrethrum isn't very much different from the synthetic pyrethroids, except that it usually doesn't last as long. And if it's not mixed with a synergist, sometimes if you just put straight pyrethrum out, you can get this quick knockdown of things because it affects the nervous system. But if you don't have a synergist in there to keep the insect's body from detoxifying the pyrethrum, then they can bounce back after an hour or so. So try to get things that have synergists in them. That's pretty important for pyrethrum. Rotenone, this is one that I think is not necessarily available anymore. I think they're trying to get rid of this. They're linking it to neurological disorders in people. And this is a botanical, but it could potentially be bad. So keep that in mind. Spinosad is not a botanical, but it is from a bacterial fermentation. This is another product that you can get in an organic form, so organically certified. It works great on a broad range of things. Anything feeding on leaves generally. There's contact knockdown with these, and there's also ingestion knockdown as well. So this works pretty good. It's a little more expensive than using a carbamate. You have to apply it more frequently, but this is an option for sure. Spinosad, good stuff. Works well on thrips too. So insect resistance management. You heard this term before? And this comes down to making recommendations for pesticide use. So how does the resistance work? So resistance means basically that the chemical you're using is no longer killing the intended target, right? And how it works is, every population of insects, there are a few individuals that have resistant genes. They're not going to get killed by the stuff you're using. And so you use it, and the homeowners do this all the time. They have a jug of something, and they use it for years. And over the years, they're selecting for resistant pests. So here's our example. So you have this chemical, let's say it's 7. You mix it up, spray it to your aphids, and it does a pretty good job. Maybe you kill 99% of those. But still, some are left behind that weren't killed by the pesticide, and they produce offspring, some of which are also resistant. And then a couple months later, the aphids kind of pop up again. You reach back in for your 7, do it again. Except each time, more and more resistant individuals are being selected. And at the same time, you're killing off your beneficials usually. Because, aphids as an example, maybe they go through 10 generations per summer, whereas ladybird beetles, ladybugs, maybe 1 or 2 generations per year. So it's a lot harder for these to bounce back quickly, where for aphids, they can pop back pretty quickly. By the way, that's all original artwork. It's like a 3-hour slide here. But anyway, so you can see it. Then you apply again, and eventually you have a population that's pretty much resistant. And how you deal with this is pretty critical. So resistance isn't just resistance, of course. They have to make it more complicated. There are all kinds of different resistance. Since I'm limited in time, I won't go into too much detail, but metabolic resistance, that's where, so your body's able to detoxify toxins when you take them in, right? Insects do the same thing. So if the chemical hits them, it goes into the body, and there are enzymes in there breaking down those chemicals and getting rid of them. So if you apply the same insecticide over and over again, those insects might become better at detoxifying their body from that particular chemical or closely related chemicals. So that's metabolic. Target site. The chemicals, they're binding to sites in the insect's body, and it's kind of like a lock and key. So you have this lock inside the insect's body, and the key would be the pesticide, and it fits in there, and it keeps that site from doing what it's supposed to do to keep the insect alive. But over time, if you keep using the same thing, the insect's body can change the shape of that lock, and then the pesticide no longer fits. So that's target site. Penetration, I saw a talk on bed bugs, and they were talking about the use of diatomaceous earth, and can the bed bugs build resistance to that? And somebody actually was cutting bed bugs and measuring the thickness of that waxy layer. So they can either, make their cuticles thicker, perhaps, to slow down the penetration of pesticides into their body, or maybe they change, the concentration of the compounds in that cuticle. Behavioral, that means just avoiding the pesticide you put down. They know what it is. They can sense it, and they just avoid it. This is pretty important, this cross-resistance. And so when we look at pesticides, they're in groups of how they work. So by their mode of action, the mode of action is how they work inside the insect's body to kill it. And a lot of the chemicals that we use work in a similar way. And so this group here, IRAC, which is the Insect Resistance Action Committee, I know you can't see this, but they've broken down the pesticides into groups. This is all about insecticides here. But so they have group 1, and it goes all the way up through group 28. So all the group 1 insecticides, they work very similarly inside an insect's body. So let's say group 1 is the carbamates. So 7 was an example of a carbamate. If you find that your aphids are now resistant to 7, then don't go to the store and buy propoxyr or bendiocarb, another carbamate. Because there's a good chance that they're also resistant to that chemical too. So the take-home point here is that if they're resistant to an active ingredient in group 1, they want to recommend one of the other 28 groups. And not all of those groups will work on all pests, so you have to have some knowledge here. But that's what this handout, which I have a bunch of right here, will tell you. So what we want to do is rotate chemicals. And we rotate them by their mode of action or the main group. So here's how am I done? Okay. Well, I would recommend going online to IRAC. It's IRAC. Anyway, it's IRAC-online.org. And pick one of these up. But basically, if somebody comes in and they tell you that they've been using 7 for a couple of years and it's no longer doing what it used to do, don't recommend a similar chemical. And how do you know if it's a similar chemical? You want to find them a product that has a different active ingredient from a different chemical class. And the way you can do this is you look at the product you might recommend, you look on the front of the label. So you look on the label, right? And right on the front of the label, it tells you what the active ingredient is. And then in this handout, all the active ingredients are listed in alphabetical order. So you would go in, you see imidacloprid, and you go to imidacloprid on this, and you see it's in group 4. So then we would want to recommend something that's not in group 4 at that point. So I'm happy to talk to you more about this. But as usual, I've talked too long about the not important stuff and not enough about the important stuff. So pick one of these up. And like I said, there are only 37 of them. So if you're here with somebody or a group of people, only take what you need. So any questions on this stuff?